can you see a difference between the water in these two kettles? At the moment, no. It's not obvious that there's anything different between the water in these kettles. You may not be able to see that the water in the left kettle has been turned on, has been boiled and let cool a bit, but the water in the right kettle has remained at room temperature. In the visible spectrum, the waters look the same. That is, they emit the same spectrum of visible light, the same colors, and we can't distinguish them. But the water, and indeed all objects, also emit another type of radiation, known as infrared radiation. Infrared radiation starts where the red end of the visible spectrum finishes at around 700 nanometer wavelengths, and it continues up to longer wavelengths up until around 1 millimeter. If we change to an infrared camera, one small like this, you'll see that there is indeed a noticeable difference between the hot water in the left kettle and the room temperature water in the right kettle. So using this thermal imaging camera, this infrared camera, it becomes apparent the temperature difference between the kettles. As you can see, the hot kettle on the left emits much more infrared radiation, shown by the brightness of the kettle using this type of camera. And the kettle on the right, which hadn't been turned on, emits far less infrared radiation. Remember, all objects emit infrared radiation, but it's the hotter objects that emit more. Applications of this are many. Some prominent ones are in thermal imaging using satellites for weather systems to help with identifying hurricanes and storm patterns. And there are many military applications such as night vision goggles and so on. Okay, so you can see here the hot kettle and my hand. You can see my fingers are colder than the rest of my hand. Okay, I'm just going to touch the outside of the kettle, and you can see some transfer of thermal energy there. And now I'm going to put my hand inside the water. Don't worry, it's not boiling, but you can see it's much hotter than my fingers. It's like a nice hot water. It's like a hot bath. And you can see when it goes on the table as well, the hot water drops on the table still emit more infrared radiation than the table. And so I'm just going to add some to the cold water kettle now, and we'll see how the waters of different temperature emit different amounts of infrared radiation. Okay, so if I pour it in, you can see it swirling like milk in tea, but it's really just waters of different temperature. And finally, I just want to show you that the same way light is reflected by mirrors and other shiny surfaces, so too infrared radiation can be reflected. So you can see here me and my reflection in the whiteboard. Okay, so I have here another application of infrared radiation, very topical one. This is an infrared thermometer. Okay, so it takes in infrared in the input through this aperture there, and it will give a reading on the screen of the temperature. Okay, so if I demonstrate it here on the kettles, so the kettle on the left is 17.2 degrees C, using the infrared radiation. I haven't put the thermometer inside, there's no physical contact. Okay, and here on the left, you can see the kettle's much hotter. All right, contrast this with a traditional thermometer in which you put it in and through conduction, heat transfer takes place, and then the temperature is gauged that way. This is purely through the radiation they emit. This is often used on people nowadays during the pandemic to measure their temperature. So I just did mine. I'm 32 at the moment. Okay, but these use the exact same type of radiation that we saw being detected by the thermal imaging camera.
Like the bees that can see in ultraviolet, snakes can see in the infrared. They have small receptors just below their eyes that allow them to see their prey in the infrared, which is obviously an advantage for hunting. Remote controls also give out infrared. That's how they communicate with your television. And if you shine it at a digital camera, you'll actually pick that up because a digital camera can pick up in the infrared as well. Fire brigade use infrared to look and find the source of fires and see particular hotspots. Also, the police use it for finding fugitives. They have infrared cameras attached to their helicopters, and in this case you can see an infrared camera used to spot a cannabis farm because of the much hotter environment that the cannabis needs than the nearby homes. And finally, the military use infrared attached to tanks and infantry vehicles and handheld, so that they can see at night time as well.